Wait, let's first make it work because Arthur says he can't.
Yeah, I will just try to figure out if the
He can't speak. But what can I do? Why is that? It unmuted me now. All right. Can't hear you there.
I don't know if you can.
Oh, yes.
Can you hear me?
Yes. Awesome. So you can also hear us.
Yeah.
Oh,
I don't.
perfect.
All of a sudden it worked.
Okay, it works. Oh, awesome. All right. That's great. So maybe like 2 more minutes or something. Let's see. I can position the camera a bit better. And then leave that. Yes, we can hear him.
No, but on the stream. Matthias, can you just say something? Yeah. Yes, all good. It's with the delay, so we heard it.
So why didn't you get now the speaker?
No. Don't worry. That was from the past.
Yeah, that's true.
Oh, it was from the past. All right. Because there's a delay. Sweet. Okay, that's great.
So we are ready when you're ready.
Yeah, that's lovely. Is Mathias still?
Yeah.
Yeah, I can. I just think there's no video yet or screen share.
Sharing. Should I share?
Okay, perfect.
Guys, we have a speaker here, so we're starting.
I can't really hear you if you're saying something.
We didn't. Can you hear us now?
Far away, like very choppy.
Oh, great. Can we somehow? I hope it will kind of work. Turn off some things, but it should be good. It should be.
I can't hear what you're saying.
So you're in the chat?
Yes, I'm in the chat
And
and I'm
unmuted.
unmuted, yes.
But it worked before. Did it work before? Does it work better now? Why though?
Yeah. Oh, maybe we
can you
should
share the link? Maybe I can try that one.
We should use Keith.
We should use Keith.
Connection maybe, or my connection. I don't know. Now it's fine.
It's fine now. All right. Okay. Ah,
It's just kind of like
next
that
time we need
connection.
360 camera to capture the whole audience. But okay. All right.
Okay, let me try here. Let me try to disable my VPN. Okay, maybe that helps. I cannot hear anybody. I can see you though.
You can see. Oh, great. But you should be able to hear us. No, you can't. Why is that? It didn't work before. What did change? Did we change anything? No.
Maybe turn off the screen, the video
video
For a little bit, yeah.
for a little bit. So, are you in though?
Say something.
I will rejoin. Let's see if
Yeah,
Yeah.
rejoin.
and this is I'm the sound also, Alex.
Yeah. Are you in?
Yes.
I'm wondering. Can you hear me better now?
Hear you fine.
What did you say?
I said I hear you're fine, or like at least way better.
Oh, you hear us fine.
So we also hear him fine.
You're fine.
Okay, then everything.
Just to get his screen and then we're ready.
That's sweet.
Yeah, my screen.
Okay.
And OBS also seems to work, so maybe it will work out fine.
But I don't see the stream. How can I do that?
You don't need to see it.
You do see it. Okay, but it would be cool if we can see things. No. So should I rejoin too?
Yeah.
Lovely. I think we need to use Keith soon. This is madness.
You ready?
Yes.
All right, that's all good. Just to make sure. So, one second.
Thank you.
So you can see my screen now.
Yes.
You can see that, the hole punch.
Yeah. It's
Sweet.
punching a hole into the screen.
Awesome. Oh. Awesome. So, yeah, thanks for having me. I love peer-to-peer events, and I love community getting together and talking about things. So let's get started. Yeah. So yeah, that's the Holepunch. If you don't know, this is a presentation I did recently in Germany. I just updated a little bit, but basically we're going to be talking about Holepunching today. So Holepunch is also a company. It's the peer-to-peer company, TP2PC. I like to do acronyms now. That's my new thing. So basically, if you don't know who I am, I'm Mathias. That's my handle on all the things, except in the peer-to-peer world, where I'm just known as Public Keys. I live in Copenhagen, Denmark, which is pretty close to Wales, so it's pretty nice. At Holepunch, we are all remote, but we are around 10-15 people now, all working on peer-to-peer and apps. Very exciting. And I've been involved in coding for a long time. I've have tons of repos on npm and tons of node modules online. So if you use Node.js, you probably use my stuff. That's what I'd like to say. And if it breaks, that's sad. If it doesn't break, that's awesome. But it mostly doesn't break, so that's really good. Also, we're continuously hiring. So if you're interested in working with Node.js and peer-to-peer and all that stuff, we have a recruiter online now. It makes it very easy. You can just go in there and see what we're hiring for and apply. We actually have a ton of people already applied, so we're not always the fastest to get back to, but we will. And yeah, it's super awesome. So basically, I just want to talk a little bit about something that's close to my heart, which is basically, the swarm and why we need the swarm and why the cloud is like ancient history. So, where all of us sit on these powerful computers every day. So basically, we all have laptops. We seldom use all the power of our laptops. They just get faster and faster, even though we we don't really consume much more about them. They also have pretty powerful drives and lots of storage these days, and some of us have, if we're working professionally with them, have more than one. I'm actually sitting here with like 4 computers. Some have fewer, but most of us have access to a laptop or a computer every day. We also have, at least like in our part of the world, pretty fast or very fast home internet connections. There's been a lot of infrastructure put in place the last 5-10 years to put gigabit everywhere, and we don't all have gigabit, but we all have access to pretty fast stuff, and we all pay tend to pay these monthly fees for them, and it's like kind of like part of our essentials. And then finally, like most of our actually includes own multiple computing devices like phones. Actually, I think my phone now is more powerful than my laptop, and it's kind of crazy. And watches people have and all this stuff. So we have just tons of computing. We never had more than computing. It's kind of insane. Yet, the sad thing is that we only use very, very little of it at any point in time. So there's like something off here in the way we do computing today. So basically, this opens this question of like, why do we even need the cloud? Because we have all this, the stuff at home that's just sitting there most of the time. And if we don't have it, our friends probably have it, our family members probably have it. And the cloud is just kind of like somebody else's computer anyway. So why has there been this push for the cloud in general? So basically, I like to say that the game is rigged. And what I mean by that is like this has been a process that's been happening the last 10, 20 years in all of computing. So basically, we all have these powerful home networking phones, but all of it is locked down. And what I mean by locked down here is like the networks are locked down, which basically means you cannot run any servers anywhere because you cannot access them. So they're very logging on into this like client-only, consumer-only mode, which is very sad. We all use browsers every day, and it's almost in the name because browsers can only connect to servers. They want to have direct connections to things. So they're kind of forcing us down this model of if you want to use a browser, you need to use a server, and that server cannot run at home in practice. So you're kind of forced to use the cloud. So the whole model is just built around this thing. And finally, like, this kind of like is compounded by the fact that the internet economy is based on mining your data, basically. So like, we're not paying for anything anywhere, but we're paying with all our data. So this is all like a self-enforcing loop. That means that this is like how things are, and this is where a lot of the economy is based on online. So it's really sad. So I like to say, basically, for the future, we need a fresh start, because this is like, it's very hard to iteratively change any of this because it's all just built around the same model. And what I mean by fresh start is, we need a new peer-to-peer internet. And what does peer-to-peer internet mean? Well, peer-to-peer internet, obviously, other than the technical aspect, just like from a more high-level thing, it just means that we need users in control. We need to remove this differentiation between clients and servers. Everything is just computers, and computers all have the same capabilities. If some want to be servers, some want to be clients, that's fine, and that should all be doable. But they shouldn't have these like outside terms dictated to them. Obviously, we need like some base foundation of this internet. Everything needs to be private and encrypted per default, not like opt-in. There has to be like an absolute necessity built in. You should not be able to do anything on this internet that doesn't have those foundational pieces in. That's just how the modern world works, and we have very good and very powerful primitives for this already. So there's like really no reason why not to have that. And finally, any kind of peer-to-peer internet has to, from an infrastructural point of view, be operational without any need for token or shitcoins. It should all just be clear infrastructure. That's not saying you shouldn't have commerce. We want to have tons of commerce on this. It just cannot be baked into the infrastructure, because the infrastructure should always be open and free, because otherwise we're doing it wrong. Like kind of like TCP IP is free on the current internet. Like this foundational layer has to be just operational. Like obviously you pay with your compute and your own storage. I'm not saying you give anything away, but like you shouldn't be forced into some incentive scheme on this base layer. That's like one of my biggest criticisms of the way we try to do things on a lot of Web3 stuff. So yeah. So peer-to-peer internet. It's just like putting the peer-to-peer in the internet. Sounds really easy. Well, spoiler alert, it is very much not. There's a tons of challenges and problems we need to solve here. So just like quick summarization, and give me 1 second here. I'll just make sure I have the chat open also in case something pops up. No, I can't. That's fine. So basically, what do we need for the peer-to-peer internet? Well, I already touched on this, but obviously we need connectivity. So we need, that's kind of like needs to be a foundational right of every device on the peer-to-peer internet. You need to be able to be connectable, i.e. you need to be able to run servers at home, not just clients, or on any device for that matter. Like there should be no special requirements on the devices for that. We obviously need tons of new data structures because all the data structures of the old web and the old internet is kind of focused around this model of things live on a server. That's not going to fly in the peer-to-peer internet. There we need to decouple data from servers and have data just be self-verifiable, i.e. like data structures that are just described by hashes and public keys, not IPs and addresses. And also it's essential that data has to be able to swarm efficiently between peers. Like you cannot have a peer-to-peer internet where you have to connect to one peer to get all the data, unless that peer is providing a peer-only service. Like data should be able to be moved around and self-verifiable with the same constraints I just said with privacy and encryption. Obviously, we need these existing features also, and also new features. Like we need to have encryption, we need authentication. You need to know that who you're talking to is that person you're talking to, or like at least the crypto identity that you're talking to. You need to have tools for privacy. You need to have tools for finding peers, telling the network that you have stuff, et cetera, et cetera. And then finally, and this is also, I think, something we leave out a lot. We want this internet to be commercially viable. So we need payment infrastructure for commercial businesses. Like when you make apps, and I think this is actually one of those things that the peer-to-peer internet supercharges in a really amazing way. When you make apps for business or just for selling things that make sense to sell, you want to be able to, without having to compromise your entire system, be able to take payments for that. And there's a lot of really cool innovation in the last 10 years also in terms of this with cryptocurrencies and blockchains. And a lot of the stuff actually fits really well here. I'm especially a fan of Bitcoin Lightning and things like that. We need to have easy primitives for interfacing with those things without, again, baking them into the infrastructural layer. But like it's essential that you can make a viable business on this without I think there's a disconnect that people always think that peer-to-peer means free for everybody. Obviously it should be possible to make free things always, because there's tons of things, like most things probably should just be free, but like you need to be able to create businesses when you need to, so you can actually turn this into a sustainable thing for the future for the users. So that's super awesome. So the thing I'll talk about today is connectivity, because that's very close to my heart, and that's where I spent years of research and work. And I think it's very exciting. All the things here are exciting. Obviously, if you're interested in the other work, just reach out. We have tons of data structures also for the peer-to-peer web. But I want to talk about connectivity today. So basically, everything you have at home in terms of hardware that you got from your ISP is just focused around blocking all server traffic. This is very sad because, I actually don't think they necessarily do this because they're malicious or evil. It's just because in the past there was probably a ton of issues with security around this. This is part of the security discussion, obviously, also. But it's basically impossible today to run any kind of server traffic on a home network. That's all I'm saying. Because of this, like traditional server traffic, i.e. TCP servers. That's because the networks are just completely locked down. They just want to have the client traffic. They probably just want to have TCP port 80. And for free for doing the browser-based traffic, and that's it. And there's many reasons for this. But one of the reasons that are more from a infrastructural point of view is basically that the world is still relying pretty heavily on IPv4. And that's a big part of the problem also. So let's talk a little bit about why that's a problem. So basically, if you have a drawing like this, where it's you or your laptop or your computer at the bottom, then you have your home router. That's the thing your ISP sent you, or you bought one when you connected to the internet. And then people kind of think it works like this, and then that router just kind of goes out to the internet. That's kind of that's how things used to work. It was kind of you had this layer with you and your router, so you can have all your devices at home. And then they would just connect to the internet to somebody else's router, and that was really true in the past. And then this thing happened where basically we ran out of IPv4s, because there's not that many of them. There's only around 4 billion, and we have way more devices and also people on the planet. So this happened, and to avoid everything collapsing, we had to come up with a solution. And the way we solved this problem as society was just instead of your router, we just added another router. So your router had a router now. It's just that you don't have this router. It's standing on your ISP, and that router then interfaces with the internet. And that was pretty smart, because that allows us to kind of subdivide the space. So that router could describe many more devices, so only that one needed an IP, and then we could kind of just cycle them in between. It was really clever. And obviously it made everything more complicated, because routing now is way more complicated, because you have these extra intermediary layers that's very hard to address, because you don't have an address anymore. Only your router's router have an address. And so, that was fine. It kind of worked, but then with everything else, the internet grew, and it grows fast, and still grows very fast. And the world ran out of IPv4s again. So even with this kind of indirectional layer, it was not enough, because it kind of just gave us a little bit more scale, but nowhere near enough to feed the appetite of users. So what's the solution? People can probably guess, but basically you just add another router to it. And that's kind of the situation we're in right now. So, your ISP's router, i.e. your router's router, got another router. So you have 3 routers. And then we can postpone the problem a little bit more. And I'll make this meme here. I thought it was pretty clever. So basically, from the start days of the internet, if you're around for that, but basically the problem is always just, your router just adds more routers, so it's just recursion. And that's how we solve the addressing issues of IPv4 with great complexity. So that's, very complicated, makes addressing really, really hard, makes running servers just really, really hard. So, society kind of was this is ridiculous. Let's try to solve this once and for all. So IPv6 was made. IPv6, if you don't know, has a bunch of different things, but primarily it just says instead of only having 4-byte addresses, it's 16-byte addresses now. So way, 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 way bigger. Basically, we'll never want to deal with this ever again. So anything can get an address or a ton of addresses. It doesn't matter. There's so many addresses to go around. And I get asked this a lot, why is that not just a solution? And the cool thing is that, yeah, it is part of the solution. The sad thing is that ISPs still block traffic because they don't want servers. So even though your devices have an address, so you can actually address things now, your ISP still won't allow them to accept it, because they will still block incoming traffic. And also this very sad, a lot of people don't know this, but this very sad feedback thing has started to happen, where this is a graph of IPv6 adoption worldwide. So I don't know if you can notice, but it's kind of tapering off. And the problem with that is that the more IPv6 gets adopted, the more IPv4 addresses get released, because new things gets put on IPv6, which means that more things also use IPv4 because there's more addresses to go around, because it's easier for people. So like it has this like negative feedback loop in practice, where the faster it grows, the slower it grows. Some of the conservative projections now on IPv6 adoption is kind of like 100 years in the future we'll have like critical adoption. Like obviously 35% is still very good, but it's definitely not an acceptable, number of like, hey, only 35% of users can use this thing. So it'll take a ton of time, is my guess, before we actually have critical adoption of it worldwide. It's very region-based at the moment. So it's super sad. But so basically, my point is, any solution we do, we need to deal with IPv4 for the many years of foreseeable future. So let's talk a little bit about that. So basically, how can we actually work around this? How can we, on IPv4 address or even IPv6, if it's blocked, how can we actually accept server traffic? Well, basically, we need to trick them, and this is the act of hole punching, and that's why we named our company Holepunch, because we do this for everything we do. It's essential to any kind of peer-to-peer network. And I just want to like give a little presentation on how that actually works in practice, because it's one of those like epic hacks that is foundational in how things work. So it's pretty cool, and it's also really simple. The core of it. So hole punching is basically this technique of like tricking computers into thinking they're just clients when they're actually servers. So I made a little illustration here. So if you consider these two computers, there's a computer on the left and there's a computer on the right. And these computers are just home computers behind normal routers, etc., etc. So hole punching just works this way, where if the computer on the left wants to connect to the computer on the right, it will just send a packet to it. So what that does is that when it sends a packet to the other computer, and obviously I'm assuming here that they know their address and stuff like that, when you send a packet to another computer, when that packet hits your firewall, that packet has the address it's sending it to. So then your firewall will see like, okay, cool, you're sending a packet to the other person. I'm going to allow you to receive a reply now, because that's allowed. Then this packet, it gets forwarded, because our firewall doesn't know if the other person is a client or server. It just knows it's an address. It gets arrives at the other person's firewall, and then the other person's firewall looks at this packet and is like, oh no, I don't know what this is. I never heard about this IP, so I'm gonna drop it, and blocking it basically. But the cool thing now is that if out of band we told the other computer to message us back, then when they message us back, unrelated to this packet we just sent them, it hits their firewall, and then they say, hey, cool, the firewall is awesome, I'll send the packet to this other person, and I'll also allow a reply. So then when this packet reaches our firewall doesn't know that this is a new packet, because packets are stateless. It just knows that it's a reply. It's a packet that came from that server. So it'll allow it because we just opened the session before, and it just thinks that the other person is a server, and it allows it to go through. So now we're in this state of like both firewalls are open bidirectional, so they're now fully connected, so they can just spam tons of packages to each other, completely peer-to-peer. So we don't only need to coordinate this like initial handshake, which is a bit complicated, but very powerful after, because we just need a little bit of out-of-band traffic, and then all the traffic they ever want to send to each other afterwards just works. So this only works if the two peers know the IP of each other, and they know the port of each other, like the session that's been open. And IPs basically are very, very easy to figure out, because everything you do online has your IP. And again, this IP might not be your IP, it might be the shared IP, like your router IP. We don't really know, but we know that That's the IP that points back to you. You can just use these online tools if you want to. You can also just gossip them. That's what we do at Holepunch. We just peers gossip between each other what they saw. Then you can apply some statistics and figure out what your IP is without leaking it to one person. So that's pretty nice. The hard thing is that ports, i.e. not your address, but like which port you open, is actually chosen by your ISP, and you have no influence on that. This is so basically, you don't know what your port is, and only your ISP knows. So that's really tricky. So luckily, like 90% of all networks give you what I call a static IP. And what I mean by static IP is just that if you send a message to one peer that you're connected to, they can that peer actually knows what port you have because the ISP will tell them in the packet. And 90%, around 90% of ISPs will give the same port to another peer you message afterwards because they like to reuse it because it's way more efficient on their routing. So you can just have this, you can do this gossip protocol where you ask peers like, hey, what's my port? And then if you ask enough, you can kind of infer and remove like bad peers from that set with some statistics again. And then you can kind of get an idea of each of your port. So very powerful at Holepunch. We actually use our DHT for that, the Hyperswarm DHT. So it's very decoupled from specific peers. You just again, like every peer you talk to will help you gossip this. So it's very simple. That's all good. The only problem is that if you're in like an office building, or if you're in at work, then those networks can tend to be very locked down, and they lock them down by normally by randomizing ports, which means that you cannot do anything to detect them. That's super sucky, and because we don't just want to drop like 10% of all peers. That's too much because we want to try to connect to everybody. So luckily, there's a technique we can use to Holepunch to these guys as well, and it basically just involves math. So to our lock ports, the port space is very small. It's actually all ports are between 0 to 65,000 because it's just 2 bytes. In practice, it's even smaller because the first 1,000 ports is normally reserved. So we can do this technique where we try to guess it. So here's the scenario. So like assume you have 2 computers, but only one of the computers knows its public IP and port, i.e. it's on a static port, which is the normal case, but the other person is on a random network and only knows its IP. Because its port is random, so it has no idea what it is. So this would be like one person at home and one person at a locked down office network. So basically, it's this scenario here where you have the 2 peers again, but one of the firewalls have an own port and the other person has a random port. So we can try to Holepunch this network by just guessing randomly, picking we think the other person's port is just a random one in this space. That's fine, but it only works like 1 out of 65,000 times, so it's not that great. So basically, we can do this technique here where we first have the person on the random network send us a packet because they know our IP and port. So that opens the session like in our previous example. And then we just pick a random port and we send this packet to them. And if we guess correct, it's fine and it goes through. If we don't guess correct, it's just going to get dropped. So again, not that great. So how can we improve this? So basically, it's very simple, as with any good technique, in my opinion. Instead of just trying one, we just try tons. Instead of just having one random port, we just open tons. So instead of opening one, we just open 256. 256 here is just arbitrary. It's a good number. So you just open a bunch of sockets on the random one. So now when you send, you start by sending a packet to the gnome port to open the sessions like before. So now we can, if we guess correct, we can send. And then when we're sending packets, we just keep sending random packets. And if one of them is correct, it goes through and we have a connection. And all the other ones just get dropped. So we're just basically like brute forcing it in a way. So this is cool, but like when you look at this, you're like, oh, okay, this seems very inefficient. And you know, how many packets do we actually need to send to get through this? That's a really good question. And the intuitive thing to say that, oh, you probably need 60,000 packets. Actually, you don't. You need way fewer, because this is a similar math problem as the birthday paradox. If you don't know what the birthday paradox is, it's basically, you know, how many people need to be in the same room before two of them share a birthday. And it's one of those also where you think it's a lot, but it's actually only like 20 before it's 50%, because you're not comparing individual numbers, you're comparing pairs, and when you're comparing pairs, the problem turns factorial, and it's much easier to do it right. So basically, we can apply this technique and do a ton of math. I'm not going to bore you with that, but just going to give you the details here. So basically, you know, there's 365,000 options. There's 256 correct guesses because we opened 256 random sockets. If you guess roughly 174 times, it'll give you 50% chance of being correct, which is already you know, pretty decent. And as soon as you go over 2,000 guesses, i.e. you send 2,000 small packets, it's basically guaranteed to work. So that's really powerful, and I have a link here that describes in detail how this technique works, and from Tailscale. So it's super cool. And the cool thing about this is that sending packets is actually really fast, and because all packets on the internet are very small, so even when you just, you know, if you stream a movie on Netflix or whatever, the amount of packets you send per second or receive per second is insane, because every package is around 1,000 bytes. So if you're receiving a megabyte, you receive 1,000 packets. So, you know, you already sent. That's a full-size packet. The smallest packet is only around 10 bytes. So it's actually really fast and really efficient to send tons of packets. So this is very fast in practice. Or like, sorry, fast enough in practice, not very fast. So the next thing is kind of like, well, this kind of sounds like a DDoS attack, or a DOS attack, not distributed. And that's it's a good question, because basically from our point of view, when we're guessing, we're not being attacked. We're kind of attacking the other person, because we're just sending packets, and our firewall is fine with that. That's what the internet does anyway. We're not receiving packets. So that's all cool. So how can we make sure that the other person doesn't feel attacked? And we can do this by this technique where we just set very low TTLs on packages. TTL is just how long before the packet should be dropped. Because we only care about packets leaving our firewall. We don't care about the packets actually showing up at the other person. So basically, that kind of looks like this, where we just send a ton of packets, but they all just like get dropped before they arrive. So the other person doesn't know that we're basically attacking them, but we're just opening tons of sessions. So it's pretty smart, because it's like a one-way attack where the other person doesn't know they're being attacked, and they're also not. We're just hole punching. And then when the other person replies, this is kind of like happens to work. They're just like, oh, lucky guess, but actually it wasn't. It was all coordinated. So pretty cool. So yeah. So that's basically hole punching. Oh, I had a demo of this. I forgot. Let's see actually if I have this code of this here. You know what? I might skip that to the end, because I'm on a new computer. I didn't realize I moved computer. But we might come back to this if we have time. But I have a fun little demo where I hole punch. Give me 1 second, actually. Let me just see if I have it over here. I can't remember. Demo. Just looking on my other computer right now. Okay, I think I might have it. Let's see later. So yeah, that's basically connectivity. And I'm gonna try now to see if I have that code still. So bear with me. My laptop. This is punching into hole punching in here now. That was already a demo. I'll make this a little bit bigger so you guys can see. This is my computer I have at home. I just have a normal home internet. And I have a server here. Let's see if there's a chance this might not work. Let's try. So basically what this happened here was I spun up a server. It has this address. It's just a public key. It's my home network. And then I need to get file over here. And we need let's try to install that. So I'm just installing the peer-to-peer network here. Oh, quick. So again, this I haven't tested it, so this might not work, but let's try. So on the left here, I have my computer. And this one on the right here, over here, is my home computer. And I'm in my office right now, so that's a corporate network. And this one over here on the right is on my home network, but it's two different networks. And I'll do this. So if I do this, so over here, I actually did this like random penetration thing. So this was all the different sessions it tried when it was doing the Holepunch. You can see here just sending tiny packets, and here I printed it out so you could see what was going on. Obviously, that wouldn't normally happen. My that its network. So this is the good network, it's a static network, and then it's trying to crack the other network with all these ports. And then at the end here, it figures it out that it worked. And it's probably up here somewhere because it went through and then they're connected. So even though the network is super, it still works. So it's pretty awesome. So yeah, that was it. That was the hole punching demo. Connectivity is super important. That's how we do it. Super important for any kind of peer-to-peer internet. Everything else is also super important. All of this stuff is what we're trying to provide with the Holepunch platform through tons of modules. So we're basically solving all these problems. Very, very fun and interesting problems. The platform itself is basically this runtime that gives you these things that allows you to make what I like to call unstoppable peer-to-peer apps. Unstoppable because once you distribute a peer-to-peer app, nothing can take it down because it's all peer-to-peer. So like, it's not like you're relying on anything. Same for the Holepunch platform. It's not like that's relying on anything. If we went out of business, it would still run because it's just running on this on your own infrastructure and your own computers. So very cool. One of the apps we made, if you don't know, is this app called Keat. It's a peer-to-peer video and chat app that basically just takes all these features and makes a very simple chat app out of it that is just very powerful. And I'll do a little demo of that if you haven't seen it. So basically, I can spin up Keat here. This is actually just my Keat. I can make, this is just a room now. And I'll just add my other computer real quick. to my other computer.
Okay. No, that's rather not.
And I'll go back and Keat. Keat on the other computer. I'll put it in. Might be 2 muffin touches now because it's my same on both. We're actually working on files, which is a very fun cryptographic problem. But basically on the other computer now, if I write like hello here, I'll get over here and I can write hello back. Now it's on the other computer.
Could you share the room in the Discord chat? Maybe then we can even try to join. Probably goes wrong, but, you know.
No, it's fine. 1 second. Can I
Unmuted? I mean muted?
try at least? Office networks or not? Try. Actually. I clicked it. I don't know if that was a good idea.
You're unmuted? I thought you want to say something, so unmute.
Oh, yeah, it's pretty fun because you can do things like. So now I try to put my other computer on my phone.
So you can say
I
anything.
think I did at least.
Okay, I'm trying to join. Oh yeah, it looks good.
It's in the. Yeah.
That's my other computer also. So yeah, so it's kind of like you can see how you have a little call there. I'll just join for 1 second. I don't know if that's gonna mess up the other sound. So, well, actually, I can just join over here.
Say when you want to say something, Alex.
Cool. Okay, it works. That's awesome.
Oh,
That's
actually, now you can't see it here. You can't see it here.
Whoa.
Oh shit.
Okay, maybe that's too much.
I'll
but
just
it
try
works.
joining.
Sweet. I
See that I joined.
expect it to go that smooth.
Maybe muted.
Oh, and the quality seems to be even better than on Discord.
Networks.
The quality seems to be better than on Discord.
It's not that far from Copenhagen to Wales, but it's pretty far from Copenhagen and Wales to whatever data center they so that's awesome. And offline, so I'll just quit here because otherwise it's like, we also have things like file sharing in here.
This was just a demo. So now it's
Mathias. You can take it if I found it. So all these functional would work. So super awesome. Always good. A real live demo. We call it's an alpha right now because we're still iterating it really heavily. But you can get it at Keat.io, and then it's all peer-to-peer from there. It's actually all distributed on the peer-to-peer network. We just have a website so people on for bootstrapping purposes, and that's basically it. Yeah, that's the talk, and for listening.
Yeah, thank you very much. That's amazing, and it's worked quite smooth to join like from here. Even though Copenhagen is close, but like still, who knows? Usually,
I'm in my I have a co-working space, and we have a very locked down network here because it's a mega shared network. And so when you connected, we actually did a mega, the cracking of the networks to each other. So it's always good to see that doing in practice.
Yeah, the quality was even better than on Discord, I think. I mean, at least on my screen. One question. I think can we try to use it like from when on? Like I think you mentioned December.
Holepunch.
Yeah,
you mean?
Holepunch.
We're iterating right now, and we'll start to go public in December with the various parts so people can build on it. We're building a ton of around it also, so it's very easy. So basically, everything you build on Holepunch is peer-to-peer, including the apps themselves. So the apps are also distributed through Hypercores and up through the network. And the platform itself is also distributed through the network. You just need to bootstrap. So when we updates and all that stuff, I just sign them on my laptop, and we actually have a multi-sign-in that works, so multiple people can sign it, and then it just distributes from there. So super cool. But yeah. So it's coming. It's in December is the plan.
One question from me. First, thank you so much for taking time and sharing these exciting things with us. Now, if somebody wants to get ready for December and maybe already start like learning and building something, what would you recommend?
Everything we build is building on Hypercore and Hyperswarm and all our modules. We have a GitHub board and we have a bunch of workshops already. I would just get familiar with and join our Discord also. There's a Discord on the. We're gonna move that Discord to Keat pretty soon. We're launching like a Discord style rooms in there, like mega rooms. So that's gonna be very exciting. But that's join there and ask questions when you stuff like that. But pretty with web tech and the Hypercore ecosystem is very essential.
Will somebody who already knows the APIs of Hypercore and Hyperswarm and so on have certain advantage, or will you have like completely fresh new APIs?
Well, it's exactly the same APIs. So it like with a bunch of we're working on some new data structures, but it's all just modules. There's no new like, oh, I got to learn anything new. If you already know it, it's just ways to make it work better with each other and stuff.
Sweet.
Very simple and good way.
One more question. In December, like when you start open sourcing, what will be the initial features? I imagine it's Holepunch, and I imagine it will be something like Electron that might also work on mobile. And I heard also that maybe Lightning networks are integrated. Is that all included in the package in December?
I don't know if we do it all in one go, just because we kind of like, we don't want to have anything hold up by something else being in progress. But yeah, that's the plan. All of it, the Lightning stuff we're working on right now, that's our first iteration of payments, and that's actually being released in the next weeks is the plan.
Will like all of it be open source, and does it mean that I'm also running like a Bitcoin node, or is that an option, or I'm just using Lightning networks?
No, all of that be open source. You're not running anything you don't want to be running. There's like our Lightning integration is requiring your own node, because we also don't want to be custodial for anything you do. I also want to be lightweight. So we just integrate with existing things. Very simple, and all of it is very light.
I also have another question regarding the wallet. Like, do you have any kind of data wallet or Bitcoin wallet or stuff like that integrated in Holepunch?
With what's it called? Like existing Lightning wallets at the moment. So. Guys, that's very essential for the platforms. You can actually interface with payments, so you can program. When I do this, I want to receive a payment and stuff like that, and send the payment. But the actual interfacing and the wallets is maintained in your existing nodes.
So you can basically connect to Holepunch with your existing wallets.
Exactly.
Oh, okay.
Continuously want to make that better and add. We're working on tons of stuff in that space also, just for interesting iterations. So yeah.
That's amazing. And I have one more question regarding these firewalls. I mean, I am not so good in this networking stuff, but I just wonder if you reveal all your kind of crazy technique, can firewalls be somehow updated so that they don't enable this hole punching in the future, or is this something that can always work?
Great question. There's always an arms race. That's how to think about it. Where it's not actually all firewalls that want to block you. Most of them just block you for your own sake because they don't want you to be hacked by traffic. So it's but you can also layer this technique where tunnel through other peers and stuff like that if they allow you to in case you get blocked. And we haven't added the full version of that. I actually just did a release on that today, the first part of that. So you want to basically defend in depth where you have 2 or 3, so that if one of them don't work, the other one probably works. As long as you're not on the peer-to-peer, which is something very, very essential. Doing like we never compromise the peer-to-peer. We're never like, hey, it's peer-to-peer, but you have to be centralized. We're always like, no, it's peer-to-peer or bust.
Yeah, you mentioned that this kind of like extreme protection came from the early days of internet. Do you think that they will ever adapt and just kind of accept peer-to-peer and like kind of make it work without hole punching? Like that they just allow peers to continue?
I mean, that's kind of like what that's trying to do. The IPv6 still blocks traffic. Punching there is pretty simple. You still need to hole punch, but it's much simpler than the other ones. I don't think they'll ever not allow you. I don't think they'll ever not have hole punch there, because it's like then it's basically your network is open and people are gonna freak out. It's probably like a ton of software that's gonna assuming that. So, but IPv6 already makes it, not trivial, but a lot easier.
Thanks.
I also have one more question. Will you offer some sort of an app store or something where I can just download another app that maybe somebody makes by entering the punch or whatever link it is, the cryptographic link, into some sort of app launcher, maybe into Keat, and then it just downloads and starts another app?
That's how it already works, actually, without going into too much detail. So basically, Keat itself is just a public key, and everything is just launchable through the same runtime. Keat, when you have Keat, you have enough of the runtime to launch any app you make, because every app is self-described through that, and it's also self-described through what versions of the software they use and everything. So it's kind of like a container, for lack of a better word. If you paste in the future a link to your app, a punch link is just a link that contains a link to your app and some metadata, and the metadata is just whatever you want to define. So if you paste a link to your app in Keat, you click on it. If you don't have that app, that's just detecting if you ever access this app before. If you don't have it, there's going to be a dialog that's saying like, you want to launch this, and then it has enough information there to launch it. And it's using the same techniques as we do everywhere else in the Hypercore ecosystem, where everything is sparse loaded. So for example, the Keat app itself, I think, is 300 megabytes, because it's just a ton of different stuff. But like to launch the app, you only need, I think it's 4 or 5 megabytes, because that's all you need for the main path. So when you launch Keat, you're actually only getting that little part of it. So even if you make an app and you add let's say an introduction video that's like this in full HD that explains how this app works, and you just have that in your app, then when I launch your app, I don't have to wait for that to download. So it's very lightweight to launch these apps. Cross-linking them is also super easy.
So yeah, I also understood that basically when we downloaded Keat, we downloaded Holepunch technically, and Keat is just like one of the apps that is now available inside of Holepunch.
So the only thing you download basically is like the platform and then a link to Keat, because show obviously that the peer-to-peer internet is user-friendly, and by user-friendly here I mean that it's not like, hey, open this up and paste a link. It's just like I click a thing and it runs. So when you click the Keat app image or the DMG on Mac or whatever it is, then it just tells, hey, platform, launch this key.
That sounds super cool. So if I'm also opening a bunch of other app links that people might share on Keat in the future, and then maybe I can launch them, will I see somewhere like an overview over all the apps that I already installed? Like to launch them again?
We'll have a ton of stuff that that's obviously like an ongoing thing, but that's the plan. So that's basically also, in a way, your app store. And I also think there should be ways for you to share your index of apps that you have with me if you wanted to, so I can be like, like a web of apps and a cool way. Because if you and I connect once, to me who you are through our ID system, which is just like some crypto proofs, then maybe you want to share your apps also, so I can see what apps you have, because maybe there's something interesting there, etc.
Maybe I have one last question, but then maybe you can slowly wrap it up. If I install multiple apps, let's say one could be a collaborative text editor or something like that, and then I produce data, but then maybe the data that I created, I want to use it in a different app. Is there like a way where I can see all the data that has been produced with all these different Holepunch based apps, and can I share the data between those apps?
Yeah, so yes and no. You can share everything between, because it's an open system. Like it's all peer-to-peer, so like there's no data siloed and anything. We're big like fasting and and things like that are always wrong eventually. So there's not like here's the one spec all data has to follow. It's kind of like up to you as the app developer. Structure your data in a way, like through modules, for example. Then I can use the same modules and using an API, you can share the data between them, so you can interface with. So, for example, if you made a chat app, you should be able to, and you follow the key structure for chats, which is again just a module. Then you should be able to interface with my key chat in your app.
Nice. Okay.
Super. Okay, so you say that people should join your Kit Discord channel for now, and then slowly transition to the Kit channel.
Exactly. That's kind of so. If you just join the Kit Discord, we're in there all the time. Kit will have a public Kit, and I think Kit will just list that one always for testing. So if you just have Kit, eventually you get an update that has that in. So that's another way. And we're working right now in this feature we call Big Text, which is basically just like mega rooms with like thousands or even millions of people that can have moderation and stuff like that if you want to. So that's going to be super exciting. Kit right now is like small groups. So yeah.
Sorry, just wanted to say that it's awesome how I can update Kit always by just relaunching it, and this is really super novel and awesome for Linux users, especially.
We update the updater all the time also, so that's always a little bit mind-bending. So yeah, we're actually working on a big update there. So.
No, you're doing awesome job, and we're really thankful for all this tech and for your time. And just keep on doing awesome stuff, and we'll teach and use the stuff you build.
Yeah, and send people to your Discord servers.
Have a good rest of the conference, and I look forward to reading more online about all the other stuff that's happening.
Yeah, thank you so much, and you also have a lovely everything that you're doing.
See you later.
Thank you. Bye-bye.
Thank you. And just reach out with any questions you've come up with after.
Yes, absolutely. Thank you.
All right. Thank you.
Bye.